The one example we haven't looked at yet is a function where you're being asked to apply the intermediate value theorem, but it may or may not apply. So let's take a look at this piecewise example. Obviously, there's some bias in the way they ask the question. So you can see the way I'm asking it here. Show that the function below has at least one zero on the interval -1 to 1. So just the phrasing alone implies that you're going to be able to do this. And the big pitfall we have to watch out for is this. We know from our talk about the intermediate value theorem that we have to be concerned with the value of f of -1 and f of 1. So think about that, right? If we evaluated f of -1 using the correct function, right, plugging it into x squared plus 2x over x plus 2, should get 1. Excuse me, -1. And when we plug in 1, which would have to use the bottom function, you get 2. So what does this imply? This implies that obviously there must be a 0 somewhere between -1 and 1, and it occurs with values between -1 and 2. Here's your problem. The functions alone look fine, except you have a discontinuity, and it's not something that would be obvious. So let's take a look at limits. We know that there's a break in the function at 0. The question is whether or not that function connects or whether or not it actually breaks on the graph. So if we were to do the limit as x approaches 0 from the left, we would get 2. But the limit as x approaches 0 from the right, we would get 1. So what does that tell me? That this function is not continuous, and it wouldn't be an issue except 0 falls right in the interval that we were talking about. So the moral of the story is, when you're asked to apply the intermediate value theorem, the very first thing we have to make sure we understand is that the function needs to be continuous on the interval specified. And if we just graze past that and act like it's not a big deal, we could run into a situation where it actually is a big deal.